Hello, grade 8. We are today going to be talking about thinking and reasoning in mathematics. And you might be wondering what that's all about. And what I want you to do today, what the goal I want you to do is to think about math in a different way. I want you to think about math more like a mystery and using clues to solve a mystery. So specifically what this presentation or video will be about is firstly, we're going to explain how algebra is used in measurement and geometric problems. So traditionally, we've looked at algebra separately from measurement, separately from geometry. And so now I want you to take what you know in those three areas and use them together. So our second goal will be to use variables to solve unknowns in geometry measurement. So that's where we're going to see the algebra in geometry and measurement. We're also today going to refresh our background knowledge of shapes because I think you maybe forget all the things that you know. So we're going to remember some of the stuff that maybe we've learned long ago or even just last year. And then we're going to come up with a little bit of a process or some things you can ask yourself when you're solving these difficult problems. I do want to warn you that today it's not going to be as straightforward as we've had in the past. And so really, I just want you to think about math in a different way. It doesn't matter if you don't get all the questions right all the time. But I do want you to try thinking about this and understanding where the ideas are coming from. So again, you might be a bit frustrated, and that's understandable, but just remember the goal today is to just think about things in a different way. You may not get the right answer at all, but when you're reviewing the right answer, I really want you to focus on understanding how that happened. Okay, so let's just refresh our memory from way back when. When have you seen variables in measurement problems? And I think you've seen it a lot more than you would think about. So let's think about a triangle and a parallelogram, a trapezoid, and let's bring in a rectangle. And so already we can see that we've been using variables for a really long time. Specifically, when you started with rectangles way back in grade 5, and we used the L and the W to indicate length and width. And when we talked about triangles, we had the height of a triangle and the base of a triangle, and then we had these extra sides as well. In a parallelogram, again, we had the base and the height, which we know is important for some other stuff later on, and then we have this other side, C, and over here at the trapezoid, again, we have this height, which is now, we can see it's inside and outside the shape, and then we have two bases, a top and a bottom. And so we've been using variables to show different parts of shapes for a long time. And then we've even used those variables in some equations. So thinking back when we first learned about perimeter and area with a rectangle, everyone knows that area of a rectangle is length times width, and the perimeter is 2 lengths plus 2 widths. And you can rearrange those formulas however you like, but they all are the same. And if we think about a parallelogram, we learned that the area is base times height. So we've got our variables here in what we are using to represent specific attributes of the shape. But we're also using variables to indicate A for area and P for perimeter. And we've done that for trapezoids and triangles as well. So we've been using algebra in measurement for quite some time. We've just maybe never specifically said that before. So for this problem, let's look at how we can use algebra perhaps in a different way, not just thinking about formulas, but what if we have a value of a side represented with a variable? So you can see here we've got n on all of our sides, which means that's the same number. So this is the same number for each side, and we need to figure out what is n. So the question, if the perimeter of this triangle is equal to 36, what is n? So perimeter of a triangle, I know two things about perimeter of a triangle. First of all, I know that perimeter of a triangle is A plus B plus C. We just add up the sides. And so I'm just going to label these A, B, and C. And I also know from the information in this question that perimeter is equal to 36. So if I put these two things together, I can say that 36 is equal to A plus B plus C. Or I could say that A plus B plus C is equal to 36. It doesn't matter which way I write it. Traditionally, we see the P over here, so that's why I put the 36 there, but it doesn't matter. So now I could just fill in what I know here. So 36, we leave it, and A, side A is over here, so that's 3n plus 1. And now I'm going to add B, which is over here. So that's 3n plus 4. And I'm going to add c, which is 4n minus 9. Okay, so our next step, we'll leave that 36 alone for now. We'll deal with it in a bit. I'm going to collect my like terms. So I've got all of my n's. So I'm going to collect all of those n's together, and they're all positive, so we add them up. 3 plus 3 is 6, plus 4 more is 10n. And I'll do my whole numbers now. 1 plus 4 is 5. And I have plus 5 and minus 9. So that's actually negative 4. So minus 4. Okay, that looks pretty. Now this looks like a pretty standard algebraic equation. We're just going to solve now for n. So I need to get the n by itself. So I'm going to add 4 to both sides to get rid of the negative 4. So that equals to 10n minus 4 plus 4. And now I have 40 is equal to 10n. And that works out so nicely, doesn't it? I'm just going to divide both sides by 10. And now I have 4 is equal to n. So n, that's the question. What is n? N is equal to 4. And I could plug them back in here to see how long each side is if I needed to, but it didn't ask me to do that, so I'm not going to. Okay, so that's one example of algebra in measurement. Connecting algebra to geometry, we've seen variables in geometry as well. So we might think about angles. We've learned acute angles, obtuse angles, and then this here is a straight angle. And we know that the value of a straight angle is 180 degrees. So then we could say, well, these two angles added together must equal up to 180 degrees. So we could say, what is A, what is B? Of course, here we can't solve that because we don't have enough information, but we've seen variables in that way. And just like triangles for measurement, we also have triangles in geometry. So we know that the angles of a triangle must add up to 180 degrees. And so here we could say, well, if I know two angles, I could figure out this angle here. So it looks like this might be a right angle triangle. And then so if we know this angle, then we could find out A simply by taking 180 minus A minus C is equal to B, or vice versa. You can switch all those around depending on this formula here. So we've been seeing variables in geometry as well. So let's look at a problem that might occur that you've seen before. So what is angle X? I've got three angles here, and we know that from a straight angle, they all add up to 180 degrees. And so it looks like I don't have enough information here, but we see this symbol, which is really important. Remember, mathematicians don't always like to include numbers. They like to make things simple. So we know that that's a 90-degree angle. So to find X, we simply say, well, X is equal to 180 minus 29 minus 90. And I'm going to do some quick math in my head, so I'm going to take this actually first out. So then it's 90 minus 29. So X, if it was 30, it'd be 60. But I'm taking away 29, so it's going to be 61 degrees. So angle X equals 61 degrees. And that's another fast way of using algebra to solve some problems in geometry. So we just saw that 90-degree angle symbol, and that was really helpful. And so we have to now think about if somebody gives you a diagram, they might use information not with numbers, but with symbols. And so it would be really helpful for us to refresh our memory about what some of these math symbols that we know mean. So let's look at a couple of quadrilaterals here. And you can see we have the corner value. So we know that the angles of a rectangle are all equal to 90 degrees. And so we don't see a number, but we know that. So it's expected that if you see that, you know that's 90 degrees. And so there's a number in your head. We also have these little tick marks on each side, and we have two here. And so that just means that that side A would be equal to side B, and side D is equal to side C, although A and C would not be equal. So it's important to remember that those tick marks mean equal. Over here in the parallelogram, you can see those tick marks again, so we can see that this length, these two lengths are equal, and these two lengths are equal. We also see parallel line symbol. And so we know that those two lines are equal distance apart, which might come in handy in a problem. Let's look at some triangles now. In a triangle, you might see these We have these same things again, equal sides. You can see those quite often. We have this lovely 90-degree angle sign. And then we have here just a plain angle sign. So the fact that it isn't square means that it is not 90 degrees. So that's important to remember. And finally, let's look at a trapezoid. We don't have a lot of markings on this one, but we often see this little dotted line inside, or perhaps it could be outside of a shape like this. And that gives you the height of that measurement of that shape. So those are important things that we need to remember. So you might not see an H, they might just draw that dotted line and it would be there. Okay, so using those symbols, what do we know about this diagram? So you can see here we've got one number, 74 degrees. So angle C is equal to 74 degrees. But we actually know a lot more about this diagram than just that one angle. We see here we've got a 90-degree angle. And so already I could say, well, if I know two angles in a triangle, I could definitely find out what angle A would be 180 degrees minus 74 degrees minus 90 degrees. So that's something I know. I can see these tick marks here, 1, 2, 3. So I know that all of these sides are equal length. So that's interesting. Another thing I would know then, that angle A here must be equal to angle O because these two sides are the same. It must be an isosceles triangle. So isosceles triangles have two equal angles and one non-equal angle. So these two, so angle A is equal to angle, I think that's a Q. Let's just draw that in there. Angle Q. And in the same thinking, I know that angle M is equal to angle P. So there's a lot of information there. Oh, and I forgot that AM, side AM is equal to side MQ, is also equal to QP. So all really important information.